Assalamualaikum. Next Maclaurin series. If you have complete the Taylor series, then this will be the easiest part compared to the Taylors, which is Maclaurin series. For information, for Maclaurin series, using the same equation with the Taylor series. However, they have a different on the C. Okay. So for Maclaurin series, C is equal to 0, means that all the equation you can remove a C. And for the differentiation, okay, instead of the fx or C, we put a certain value. So C is exactly 0. So let's say the Taylor series, okay, this is the Taylor series that we have done before. So it means that this equal to 0, 0, 0, and 0. And then for all differentiation will be 0. So become something like this, okay, for the Maclaurin series. And this I just extend a little bit, okay, for more than 7, okay. So quite similar, except doesn't have the x minus c, we have only x, okay, x squared, x cubed, x power 4, 5, okay. So this will be the Maclaurin series, or we can say that the Taylor series for C equal to 0. Okay, to make it easier, better to do the example. So we try to find the function fx equal to sine x. Since the Maclaurin series means that C is equal to 0. So let's see what happened. First, we need to differentiate. Okay, we need to differentiate. If you remember, for differentiate sine x, become the cos x. Differentiate cos x, become minus sine x. Differentiate minus sine x, you maintain the minus cos x. And then for the differentiate for fourth time, okay, the fourth time, so it's equal to sine x. Come back, because when we differentiate the minus cos, we become the sine x, okay, because cos to sine, okay, cos to sine, they have negative will be positive. And then for this, for the fifth time of the differentiation, and this one for the sixth time of differentiation, and then for the seventh time of differentiation. So this equal to on the left side, okay, f5 will be cos x, f6 will be minus sin x, and f7 for the minus cos x. After differentiation, okay, we have to differentiate this, and then we put the value, because C is equal to 0, so we can put all the value equal to 0. If you remember, sine 0 is equal to 0, okay, sine 0 is equal to 0, cos 0 is equal to 1, minus sine 0 is 0, minus cos 0 is equal to minus 1, and this same goes to the f power 4, okay, sorry, 0 for f 5 time differentiation, okay, for 6 and 7, okay. So if you still remember graph of the sine and cos, so this for the sine graph, sorry, it's not exactly here. For cos graph will be here, okay, so 0 here. So for cos 0, of course, will be 1. For sine 0, so will be 0 the value, okay. Next, after differentiation, after put the value, okay, now the equation of the Maclaurin series, okay, we can okay, this is I made a table to so you can easily see everything here. And then this series already modified using Maclaurin, means that doesn't have x minus c, okay, so we don't have this, we have x only, because c is equal to 0. So we can substitute fc is equal to 0, so here is equal to 0. And then we have f prime c is equal to 1, f double prime c is equal to 0, means that everything here is 0. For the third differentiation will be minus 1, so this is minus 1. And then we have, for differentiation we have 0, so everything is 0 here. For fifth will be 1, 6 will be 0 for everything, 7 is minus 1, okay. So after we rearrange everything. So here is our value. Okay, so I just put here 1 to make it easier for you to do the, okay, to see. Okay, you can remove here 1 here, 1 here, 1 here, and then we can remove 0. Okay, because after this, what we have here is, okay, this the equation after we remove 0 and also the positive and negative. Okay, so we have here negative and positive. How to solve this? Okay, this is because we want to find the summation. Okay, the summation for infinity starting n equal to 0. Right now we have the pattern here for, okay, the power and the factorial is same. Okay, 1 1 3 3 5 5 and 7 7. So the pattern is quite different. Okay, right now we have 1 3 5 and 7. So we need to find the ratio for this arithmetic. Okay, so this ratio from the equation an is equal to an. Okay, I need to check the equation here. Okay, sorry. Okay, so the equation will be an is equal to a1 plus n minus 1, and this is the ratio. So for a1, okay, so for a1 the value is 3, because this one is n equal to 0, n equal to 1, n equal to 2, n equal to 3. So n1 is 3 plus, so n minus 1 will be 3 minus, sorry, this is n minus 1, okay, minus 1, and then the d ratio is set is 2, okay, because 3 minus 1 is equal to 5 minus 3 is equal to 2. Rearrange, you have 3 plus 2n minus 2, so 3 minus 2 is 1, you have 2n plus 1. So how this work, you can check, go back to this equation. So we have the same pattern here is x, okay, and then we have the numbers is same with the factorial, so the numbers now is 2n plus 1. So this one will be 2n plus 1, and the factorial will be 2n plus 1 factorial. Again, we have positive, negative, positive, negative, so we have minus 1 power of n. Since the odd number, because this one is equal to 0, n equal to 1, n equal to 2, n equal to 3. So all the odd number will be negative. So here this equation for the Maclaurin series, the function is fx equal to sine x. So to make sure, you can try, you can put the value n equal to 0. N equal to 0, we have x power of 1. Okay, this one also 0, we have 1 factorial. So same with this equation. Again. Okay, this one is forgot to put the factorial here. Okay, next. The next exercise, maybe you can try with cosinus x, okay? Fx equal to cosinus x. Okay. The best part, because the cosinus and sinus is the same thing except the different phase. So using the sin x. Okay, let me see what happened. Okay, this is the series for the sin x. So we need to change to the cos. How to do that? Differentiate. Okay, so we differentiate sin x. Okay, and then we differentiate everything here. Everything here we differentiate. Okay, so what happened now? We have, when differentiate sin, we can get cos x. Okay, so finally you can get the value for the cos x. You can make one step by step like before, but the step here we want to use the sin x. So differentiate x will become 1, and then differentiate x3 will become 3x power of 2, and then we have 5x power of 4, 7x power of 6, and go on. So you can check total value here. Okay, 3x power of 2, 5x power of 4, 7 power of 6, and then you have another 9 power x power of 8. This one for the x power of 9 over 9 factorial. Okay, And then I just split the since the 3 factorial, so it's equal to 3 times 2 times 1 or 3 times 2 factorial. Okay, so same with the 5 and 7 because we want to cancel out this. Okay, just to make it easier. So finally, this is the series for the cos x. So we have the same numbers here, 2 and 2 factorial, 4 and 4 factorial, 6 and 6 factorial, 8 and 8 factorial for cos x. Okay. Later we want to make a general solution, okay, cos x for n starting from 0. Again we have here x. Okay, so this one is n equal to 0, n equal to 1, n equal to 2, n equal to 3, and equal to 4. So we can see that it's time 2, this one is time 2, time 2, time 2. So means that the n is 2n over 2n factorial. And then because n equal to 0, you can have 1. Factorial equal to 0, okay, 1. And then still have positive, negative, positive, negative. Start from positive. So the minus 1 is power of n. Okay, so suddenly put in the same place again. So this will be the value. Can we compare with sign? You cannot see here, but we know that the for sign here is minus 1 power of n x 2n plus 1. Okay, sorry, something already moved. Okay, so here for sin x you have minus 1 power of n, same, we have x 2n plus 1, and then we have here 2n plus 1. Okay, so next they have some exercise, so hopefully you can do it using Maclaurin and Taylor series. So thank you very much. Assalamualaikum.